Okay, so here's FRQ number 9 of Unit 11 project. This one, then one more to go. Um, okay, so what we're gonna need to know, physics facts, C, dielectric constant, over D. Then capacitor discharge, a charged capacitor is when it, okay, so it'll be charged and then when it disconnects, it's gonna discharge. We're gonna need to know this again. RC, and then also that resistivity. A. And then discharge equation. V time. RC. And our charge. And that's all we're gonna need to know to do this. So determine internal resistance. So our initial voltage is V, and then, is 10 volts. Okay, we have our dielectric. And then I'm gonna look for the time when V of t equals 0. Wait. So so I would be looking for the time when our voltage is 3.7 because I'm doing 0.37 times 10, so when it's 3.7 would be here, and that'd be at 60. And then 60 minutes, that'd be 3,600 seconds. And then we're gonna solve for the time constant. R equals time constant is 3,600, and then was given 8. So 8 times 10 to the negative 6. So then our R is going to be 4.5 times 10 to the 8 ohms. And that's going to be our answer for A. And then determine A. Now let's just put this here because I think we're going to need it. Okay. And and I forgot to mention in our relevant equations the 37% rule. So when the time has elapsed exactly one time constant, it's been the voltage drops to about 37%, and that's what I did, 0.37. So determine approximate surface area. So that's our physics fact. Well, we know C K D, and then we can just solve A equals C D K epsilon naught, And then we can plug that into our calculator. And that's going to be 16.1. Oops, not here. That's bad. Sorry, area. 16.1. That's our answer. Okay. Now we're going to determine resistivity. Well, our resistivity. That's rho d a, and then we're gonna resistivity equals R A over D, and this I believe it's rho. That's resistivity, and then we're gonna substitute what we found for A and R, and we know D, and then we're gonna plug that in, and that's gonna be 7.25 times 10 to the 13th ohms, and that's our resistivity. Okay. Determine the magnitude of the charge leaving the positive plate of the capacitor in the first 100 minutes. Okay. Well, our initial charge, we'll do Q naught. That's 8 micron times 10 volts. 80 microcoulombs. And then our voltage then at 100 minutes, we know from our graph is about a little less than 2, let's call it 1.8. So Q100 equals C times V100, so 8 times 1.8, 14.4 microcoulombs. And then we're seeing the magnitude leaving, so it would be 80 minus 14.4, and that's gonna be 65.6 microcoulombs. That's our answer. I'll see you in the next one when we do our last FRQ together.